Good evening, all. My name is Ram Kumar Desmukh. Here we are in the weekly doubt clearing classes of the NPTEL course, Novel Technologies for Food Processing and Shelf Life Extension. My name is Ram Kumar Desmukh, and I'm doing PhD at Indian Institute of Technology, Roorkee, under the guidance of Professor Kirtiraj Gaikwad at Department of Paper Technology. Friends, here in this class, we are going to discuss different questions which is based on the classes of this course. Those questions will help you to solve the current session's assignment, which will help to you to qualify the course for the acquired in the certification course. I welcome you on this class. We will wait for a few minutes, then we will start. Meanwhile, I will introduce myself to all of you people. As a my educational background, I have done my bachelor's in dairy technology from an agriculture institute, College of Dairy Science and Food Technology, an ICR institute from Chhattisgarh, Raipur. After my BTech, I joined MTech in the Food Science and Technology from Sambalpur University, Odisha. After doing my MTech, I did job for 15 months as a junior research fellow in Niptam, Tanjavur. Then after COVID, I joined as a project assistant technical at the Present Institute, IIT Roorkee, and Department of Paper Technology. Then in 2022 January, I joined here as a PhD, and my research area is of food packaging, where we develop food packaging and we search for the possible alternative to the plastic or synthetic polymer is my main subject area. Then I will tell you this is the Google Scholar profile. As you can see, these profiles looks like your Facebook or LinkedIn profile, where you can see your articles, research articles. When you are doing research or you are in academia, you publish some papers. There's a technical papers which will be added to your account, and those papers are cited by others, other colleagues or other people in the same area you are working. Then you will get a citations, and your research profile or your papers will be indexed like citations H index and I10 index. I10 index. So I will explain what are these H index and I10 index for general knowledge. This citations, the total number of citations from your articles. Suppose you have two articles or 20 or 200 articles. Okay, so how many times those articles have cited cumulative? Suppose I have 10 articles and those have cited for 103, means one 103 बार जो other people have cited my paper. Okay, so H index is the maximum number of papers and maximum number of citations. Like H index is mine is 5, so my 5 articles have been cited for 5 times. And I10 index is like how many articles you have, those have cited for 10 times or more than 10. So that is a I10 index. So this is the Google Scholar profile. When you will publish papers or you will work in academia, you might publish some papers. Those will be uh, indexed in the Google Scholar. And you can also search, if you don't have a Google Scholar profile, still you can search or scroll the articles you would like to read on the Google Scholar. That is a freely available, or it is a open source site like Google. Like we search something on Google, you can go to the Google Scholar site, and you can search whatever you like to read. That will be technical papers available on the site. Those have been published by the different authors from the all over the world. So that is it from this Google Scholar profile. So hope you understand this. So question first for this class: which of the following is the mechanism of preventive type of antioxidant action? So options are A, suppress free radicals formation; B is suppress chain initiation, suppress chain propagation; and D, repairing damage caused by the generated free radical. Sorry. So please let me know in the comment box if you know the answer. Then I will answer which will be the correct answer for this question. Which of the following is a mechanism of preventive type of antioxidant action? So you need to tell preventive oxidative action. Okay, so Sevali Tripathi has answered this. She's saying that suppress free radical formation. So, okay, let's see what is the correct answer. And A, suppress free radical formation is the correct answer for this question. So, preventive type of antioxidant act to suppress free radical formation. Then radical scavenger oxidants suppress chain initiation and break chain propagation. Repaired, and do you know antioxidant repair the damage caused by the generated free radicals. So these are the three steps involved in the antioxidant activity. When antioxidant works, so there will be initiation, propagation, and the termination steps occur. So the preventive type of oxidation is the first step of the antioxidant mechanism. So the right answer for this question is the suppress free radical formation. So they will try to suppress the free radical formation, and it will help to extend the shelf life of anything which is tend to go undergo oxidation process. Then question 2 is what is the correct order for HACCP procedure? That is a hazard analysis critical control point. You might have heard if you are from the food or food production or any agricultural course, HACCP procedure. So you have to manage, or you have to arrange in a correct order. So there are seven steps or seven points they have given. So you have to arrange which is first and second, third. Like you have to arrange in the step by step. So your options are given. So please see the question, and please let me know which will be the correct answer for this question in the comment box. So first is the determination of CCP establish documentation concerning all procedure and records, conduct a hazard analysis, establish the corrective action to be taken when monitoring, establish critical limit, establish procedure for verification to confirm the HSCCP is effective, establish a system to monitor control of the CCP. So as I told you in earlier classes, so Sifali has given the answer B. So if you know one or two points in the process, you can easily predict or you can guess the right answer. I think all 90% or like it will be 100% correct if you know one or two process or two steps. Like here, to like establish documentation concerning all procedure and record. So this will be the last, I think this will be the last step. So your A and D options are excluded. Then you have a B and C. So 5 is a establish a critical limit. So that is also a third or fourth step. So you have a B option, which is a 3, that conduct a hazard analysis. So the first step is to conduct the hazard analysis. Until or unless you conduct any hazard analysis, you cannot do all other procedure. So the right answer will be B, 31574764. So first will be the conduct a hazard analysis, then determine the CCP, that is a critical control point, then establish a critical limit, then establish a system to monitor control the CCP, then establish the corrective action to be taken when monitoring, then your establish documentation concerning all procedure and records. So this will be your correct answer. Okay, Sefali, good. You are giving the correct answer. I think you are from the food technology background. You are doing good. Okay, so for so B will the correct answer, and the detailed solution is also saying the same. So first, conduct hazard analysis, determining the critical control points, establish critical limits, establish monitoring procedure. Sorry, establish corrective actions, establish verification process, and establish record keeping and documentation procedure. And the third question is, match the following with their bioactive compounds with their functions. So we have a one side they have given some bioactive compounds, and the other side they have given some function. So those functions are correlated with their functions, like some bioactive compounds helps to reduce the heart attack, prevent prostate cancer, bone health, improve GI tract health. So you need to connect from one side to another side, like 1 to D or 2 to C, whatever. So, like lycopene, what lycopene does, reduce heart disease risk or prevent prostate cancer, bone health, improve GI tract, or omega fatty acid. Which what is the function of omega fatty acid? Inulin. What is the function of inulin? Isoflavone. So please, if you can answer, please write in the comment box. Like I've told you, if you know the one or two answer, you can predict which will be the correct answer. So I'll wait for some moment for your answer. Okay, so let me tell you the correct answer. So one is the correct answer. Uh, lycopene helps in the prevent the prostate cancer, and omega-3 fatty acid is good for the reducing the heart disease. Inulin is good for GI tract health, and isoflavones are good for bone health. So our answer is correct answer will be B. And the fourth question, energy required to reduce the particle from mean diameter of 10 millimeter to 3 millimeter is 11 kilojoule per kg. Using Rittinger's law, calculate the energy requirement to reduce the same material from diameter of 3 millimeter to 1 millimeter. So for solution of this question, you need to know what is the Rittinger's law, then you can solve, because this question based on the Rittinger's law equation. So if you know the Rittinger's law equation, you can solve this question. So I'll give you some moment to try, then I will tell you what can be the solution or what will be the right answer for this question. So I'll tell you a little bit about Rittinger law. That is, Rittinger's law stated that the energy required for the reduction in a particle size of solid is directly proportional to the increase or decrease or change in the surface area, okay, or surface uh, dimensions. So you think what can be the formula we can use for this question? So detailed solution is here. So as I told you, the energy required for the uh, change in the shape or reduction of the material's diameter or area is directly proportional to the changes in the uh, dimension or diameter of your material product or feed. So here what we get in the equation is a E equal to K bracket 1 upon X P, that is a diameter of your product, minus 1 upon diameter of your feed. So from 10 millimeter to 3 millimeter, okay, to reduce the diameter of the particle from 10 millimeter to 3 millimeter is 11 kilojoule. Okay, so we have a first case where the energy is given, that is 11 kilojoule per kg, and k is that Rittinger's constant, Rittinger's uh, constant. So that will be k, and 1 upon bracket में 1 upon 3, that is a product, and 1 upon 1 by xf, that is a your feed, that is a 10 millimeter. So when you solve this equation, the k will be the 47.14. Then the second case is to calculate the energy requirement for the same material. Okay, so first for the first material we got the constant, that Rittinger's constant is a k, that is 47.14. So we can calculate the energy for the second treatment. So that will be E equal to k, bracket close, uh, bracket 1 upon xp minus 1 upon xf. So here for 1 upon 1 minus 1 upon 3, that is a feed. So if you will solve this equation, so you will get the energy requirement for this treatment is 31.43 kilojoule per kg. I hope you got the solution. If you have doubt or you need me to explain again, please let me know in the comment box. This is basically based on the formula or formula based question. If you know the formula, so you can solve easily this question. So that is a this is based on the size reduction of particles. So if you have gone through the lectures uh, from the video, you might have uh, gone through these similar topics from where these questions arises. Okay, so I assume that there is a no questions from anyone, so we will move forward. So again, we have a question like a pulse mill grinds Bengal gram having volume surface mean diameter from 2 millimeter to 100 micrometer. What is the ratio of retangles to kicks constant? So here we need to find out what is the ratio of retangles to kick constants. So here what you need to do, you need to solve the same treatment with a one retangles law with a retangles method, or the same problem with the kicks constant. So I'll give you some time to uh, solve it, then I will explain you further what will be the correct solution and answer for this question. Uh, so I will explain. I will let you know the retingers and that kicks constant or kicks law are basically for the size reduction of particles, where retingers law says that the energy required for the reduction of any material size will directly proportional to the changes in the uh, material size. Okay, so whatever the material size will be changed, the energy will be directly proportional. And Kick's law says that the energy required for the reduction of any material will directly proportional to the their product to feed ratio. Means suppose your product has a 3 millimeter and your final your feed is a 5 millimeter, and your product is a 3 millimeter, so your energy will be directly proportional to the 5 upon 3. So they are saying like this, so you need to solve like this. Then what you need to do, at last you need to find out what will be the ratio for retangles to kicks constant. As I believe that this is the 10th class, a 10th week class. Okay, so we have only two remaining classes in coming next 2 week, and I think exam will be conducted on the this last week of this month. So I assume that you all are preparing at your very best capacity, and I hope you all are getting the classes and the solution or doubt clearing classes. And if you have any doubt, you can ask us in the live classes, or in the mail also you can ask. And if you have any doubt, you can ask for the study material or solution, or any kind of help you would like to want from us. Because this class is organized, this type of initiative have been taken for the to help you guys. Okay, so please let us know if we can be helpful to you. Okay, so let's see what will be the solution. Okay, so Rettinger's law, as we are seeing, we have seen in the last questions, the Rettinger's law equation formula is equal to uh, Rettinger's constant, then into bracket 1 upon diameter of product minus diameter of feed. So that will be, if you will solve like this, so Rettinger's constant will be Kr equal to E upon 9.5. So that will be the according to the Rittinger's law. And according to the Kick's law, the formula will be E equal to K, and K like Kick's constant in log that XF, that is a uh, product feed diameter upon product diameter. So if you will solve this, that will be uh, uh, Kick's constant will be E upon 2.995. So what are the thing? Ratio of Rettinger's to the Kick's constant. So Rettinger's Rettinger's constant upon Kick's constant. So that will be 2.995 upon 9.5. So if you will solve this, the answer will be 0.3153 millimeter. And if you will solve this, if you will convert this in a micrometer, so you need to multiply with 1000. So that will be 315.3 micrometer. So your answer is D, 315 micrometer. So this is the correct answer. Or you can say the ratio of the retangles to Kick's constant will be 315 micrometer. I hope you understood this question. So you have a one condition only. The surface mean diameter is reducing from 2 millimeter to 100 micrometer, and you need to put this data for one for Rettinger's equation and one time for Kick's equation. Then you need to do Rettinger's upon Kick's constant, and you need to solve the equation, and you will get the correct answer for this question. So I hope you are getting this. Please, if you have any doubt, please ask me or let me know if you need help to understand this question. Okay, so ask me if you have any doubt in any later also. So moving forward to next question. Rice milled rice is milled from 7 millimeter to 400 microns using 10 HP motor. Using Kick's law, calculate the HP requirement of motor to reduce the particle from 7 millimeter to 100 microns. So the same thing we have to apply it where we need to find out the energy requirement or uh, power capacity for the motor using the Kick's law. So here we need to put the Kick's law formula to find out this what is the capacity will be the what will be the capacity of motor to reduce the particle from 7 millimeter to 150 microns. So please, I have given you the formula in the last question. So try to solve it. Then I will tell you what will be the answer for this question or solution. Okay, so here what we need to do, you need to solve the first experiment like size reduction from 700 millimeter to 400 micron using 10 HP. Through this treatment, we can find out what is the Kick's constant. So equal to Kick's constant log then xf upon xp, that will be 10 equal to Kick's constant in uh, 7 upon zero point 0.4. So it will be Kick's constant will be 3.494. Then you have to apply or you have to put this Kick's constant for this second experiment. So you need to put in the same formula like equal to Kick's constant log xf upon xp. So you can find out what will be the correct answer through solution of the equation, and your correct answer will be 13.43 hp. So the 13 to 14 HP motor is adequate to grind the particle from 7 millimeter to 150 microns. So that will be the correct answer. So like this kind of questions are helpful in size reduction experiment when you are doing some kind of size reduction, like suppose you have a you are from the food technology or pharmaceutical background, where you are grinding your bulk material into smaller or powder material. So suppose you have some materials which have larger particles, and you need to grind it to the minute particle or in a micron or nanometer, whatever the size reduction level you want. So these formulas you can apply, and you can find out what will be the energy requirement for this particular treatment. So all the things which we are seeing today are basically based on those laws or those formulas or those rules. Okay, so on that basis they have given the questions which we can apply, and you can solve the questions. And this is also you can use in particularly if you go to the where these formulas applied. So they use this kind of calculation every day. How much power they will require, how much dimension will be changing, or whatever the parameters they will use. So they are doing it every day. So these all things are important even in your I will not say in your daily life, but if you are going to the your professional life, you are going to some food processing plant or pharmaceutical plant or whatever plant you are going, and you are working on the same field, so you might will encounter the same kind of circumstances where you need to apply this kind of laws. Okay, so moving to the next question. Section 8, the LDPE PP, that is a polypropylene and saran, as used as a three layer for packaging as packaging of food material with a thickness of 30 micrometer, 15 micrometer, and 10 micrometer respectively. These layers have oxygen permeability of 1800, 600, and 300 STP micrometer per meter square per day, kilopascal respectively. What is the effective permeability of composite material? So we have given the thickness of the different polymer LDPE, PP, or polypropylene and saran, and the oxygen permeability also given. And you need to find out if we are making the composite film of three those all together, like LDPE, polypropylene, and saran. Okay, so what will be the effective permeability? Means after making the composite of these three polymers, what will be the resulting permeability? Okay, so you have option. So if you know, please try to solve the question, then I will explain how you can solve this question, this kind of question. Okay, so we will see the solution. So solution is a very straightforward. You need to just put the formula, whereas formula is the cumulative effective permeability equal to the total thickness upon the thickness of first material upon the permeability, then plus thickness of second material or the PP upon permeability, then plus thickness of the saran and the permeability of that material. Then you have to solve this question, solve this formula, and you will get the answer. That will be 18.97 STP micrometer per meter square of per day kilopascal. So that will be the effective permeability when we are making a composite. Okay, so I think you are getting the point. What I'm saying, what I need to explain. You just need to you just need to remember the equation here. Then you can solve this question easily by calculating the amount. You know, you just need to solve this equation by putting all the values, and you will find out what will be the correct answer. So here, correct answer will be the D, 18 to 90. That will be 18.97 STP micrometer per meter square day per day kilopascal. And question 9, that is uh, one particular case is given where you need to read it, and you need to find out what are the following questions are saying, and you need to find out what will be the questions answer will be there. So I will once read the full paragraph or full the case, then we will go through the one by one the questions. So question 8 to 14 are based on the following paragraphs. So paragraph are saying microalgae can be used to make several useful products such as oil, pigment, protein, etc. In a microalgae processing plant, Floria vulgaris are used for oil production. The process consists of cultivating pure culture in a photobioreactor, followed by dewatering, drying, and finally solvent-based oil extraction. After cultivating pure culture, 100 kg of algae suspension containing aqueous media and microalgae cell in a 16 to 40 weight per weight basis, weight to weight ratio, is sent for the dewatering in a centrifuge. The dewatering yield 15 to 45 kg of wet biomass. This biomass is then dried to obtain 8 kg of dried biomass. The drying process removes all of the water left from the media that was not removed during the dewatering process, along with all the cellular water from the microalgae cell. The dried biomass is then sol subjected to solvent extraction. For every kg of dried biomass that enters the extractor, zero point 0.8 kg of methanol is required. After the extraction process, the solid cake was found to contain 0.6 kg of oil, while the methanol extract consists 5 kg of oil. The following assumptions are made in the whole experiment. First is that the aqueous media can be assumed to be only water, and the mass of dissolved solute can be neglected for the all calculation. No loss of any biomass or its component occur in any step. The microalgae mass can be taken as a mass of oil, mass of cellular water, and mass of non-oil component other than water. Fourth is after the solvent extraction, the solid that are separated consist of all the non-oil component that are the present in the biomass. And fifth is the dewatering process only removes the media and does not remove the water in the cell of the microalgae. Okay, so please read this case once, then we will go to the next class, next question, the following question for this paragraph. Summer has come, and you need to be hydrated. Okay, so we will go the following question one by one. So next question is what is the percentage of media water that is left along with the biomass after the dewatering process? Okay, so options are A 2 to 3%, 8 to 9%, 11 to 12%, and 22 to 23%. So first we will see what is the question. uh, we have a 100 kg of algae suspension, okay, that contains aqueous media and microalgae. So your here 100 kg of feed you have, okay, that is a 60 kg of media water and 40 kg of cell is to fed to dewatering. The output from the dewatering step is a 45 kg of biomass and water is removed, which will be 100 minus 45 equal to 55 kg. Okay, then you have a 60 kg of media water, then 55 kg. The 5 kg of water is left along with the biomass, and you need to find out what will be the percentage that 5 kg is 60%, 60 kg. Okay, so when we solve the what will be the percentage of 5 kg of total 60 kg, that will be 8.33%. So your answer will be 3, 8 to 9%. The answer is lies in between the 8 to 9%. So your correct answer will be B. The 8 to 9% is the correct answer. Okay, all the solution have been given in the paragraph. So when you carefully read the case, you can solve the question from that itself. So this is a easy. I think if you know the basic maths, so you can solve these questions easily. Okay, what amount of the total water is removed in the drying step? Okay, so you need to go first. Uh, the biomass is then try to obtain 8 kg of dried biomass. So your answer will be the 40 kg of water enters the drying step. After the dewatering step, 8 kg of, so total water removal. Okay, so 45 kg of water enters into the drying step after dewatering, and 8 kg of dry leaves, okay, remaining, or that is a your solid biomass. So the remaining will be the water removed. So your 48 minus 8, that will be 37 kg of water is evaporated during the drying process. So that is your correct answer for this question. What percentage of total water removed during the drying step in the cellular water? Okay, so that is a 13.5, 86.5, 80%, 20%. So total water removed during the drying step in cellular water is, you need to find out. Okay, so let me take you to the drying process. Remove all the water left from the media that was not removed during the dewatering process, along with the all the cellular water from the macroalgae cell. Okay, so 50 kg of water enters in the drying step after the dewatering steps, and 8 kg of biomatter left. So that is sorry. So 37 kg of water evaporated, and 5 kg is media water. So therefore 32 kg of water is cellular water, and percentage of cellular water of total water is the 32. What percentage of 32 of total of 37 kg of water? So that will be 86.49 percentage. Means you need to just find out the percentage. Like suppose what will be the uh, uh, 5 kg of 5 kg. What is the percentage of 5 kg of 100 kg? Like this. So you need to solve a question like this. Okay, then you can find out what is the correct answer. What percentage of total water removed during the drying step in a water? Okay, so out of 37 kg of water evaporated, 5 kg media water, percentage of media water is 5 kg. So you just need to calculate the percentage of 5 kg in 37 kg of water. So that is a 13.5 kg, 13.5 percentage. Okay, so that is a B, 13.5. What is the amount of methanol that will be required for the solvent treatment? Okay, so we'll go back to the question. Every kg of dried biomass that enters into extract, uh, that is a point 6, 0.8 kg of methanol is required. Okay, so for every kg of dried biomass, so dried biomass is we have a uh, 8 8 kg of biomass we have, and each kg of biomass will require 0.8 kg of methanol. So you can calculate here 8 kg, and per kg of biomass will required zero point 0.8. So you can calculate the for 8 kg how much methanol will be required to, that will be 8.8 kg. So that will be C 6.4 kg. So the total amount of dried feed entering the extractor is 8 kg, since zero point 0.8 kg of methanol is required for each kg of dried feed entering the extractor. So total 6.4 kg of methanol is required. So that is your correct answer. Which of the following amino acid does not contain a chiral alpha carbon? Okay, so I think okay, this is a last week question, I think. Okay, but anyway, we can read it and solve it. Which of the following, like glutamine, glycine, leucine, isoleucine? So about 20 amino acids are needed to make all the proteins in the human body, most of the other life forms. These 20 amino acids are L isomer, L alpha, uh, alpha amino acids with the R absolute configuration. All of them except glycine contains a chiral alpha carbon. So the answer is a uh, glycine. That is a B. What is the percentage of cellular water in the microalgae cell? The feed content is 40 kg of microalgae cells. Also, the percentage of cellular water is 32 kg, as established in the question number 13. Therefore, the percentage of cellular water is total percentage of like uh, 80 that is 32. What percent of 32 will of 40 kg? So that will be, if you will solve the question, solve the equation, it will be 80 kg, 80%. So this is the correct answer. So I think these are very basic questions. When you read the paragraph or case, you can easily find out what will the following questions answer. Uh, then what is the percentage of oil in the micro algae cell on a dry basis? So answer is A. Okay. Okay. Sorry. So what is the percentage of microalgae cell in the dry mass? The total feed content is 40 kg of microcell. Out of 32 kg is a cellular water. So 8 kg is a dry solid. So oil plus non-oil. Then total oil extracted is a 5 plus zero point 0.6, that is a 5.6 kg comes from the solid. Therefore, the percentage of oil in the micro algae cells in dry mass is a percentage of uh, percentage of 5.6 kg out of 8 kg. So that is a 70%. Which of the following is a good manufacturing practices in the food processing equipment? That is your options are less disassemble part of possible in the processing plant, flat bottom vessels, round edge of the vessels, and all of these above. So I think this is a C is the correct answer. More disassembly component makes cleaning easy. Flat bottoms vessel restrict flow of liquid out of the processing plant, and remaining residual fluid in the vessel may harbor microbial growth. Round bottom vessels makes cleaning easier than vessels than sharp bottom in the good manufacturing practices. So the correct answer is uh, round edge of the vessels that makes easier. Like you have seen that utensils those have a round bottom, so you can round edge bottom. Okay, so you can easily clean those spots. You don't have a very corner like those round edge vessels have no corner, so you can easily clean like these big vessels. If we have a big vessels, those used in the food manufacturing plants or dairy plants. So those for those vessels, it is very easy to clean them. So for good manufacturing practices, we need to uh, have those kind of vessels. So the correct answer is C. So that's all for this class. And if you have any questions, you can ask me in this class also, or this is my email ID where you can email me and ask me any question you want to ask about the lecture, and the resources also you can ask. Or I think the NPTEL team provides you the link and the backup files like PPT and videos are also available. But I think you also get the YouTube link that is there. You can see the full explanation, so you don't need to download videos from the backup file, or you can download my PPT from the backup store from the link. I hope you guys uh, understood the present class where we have discussed different questions based on different treatment. And as I told you, maybe in the coming in the last week of this month, the examination will be occur. So I wish you are preparing very well for this certification course, because you need to acquire at least 40% as per my information. I don't know whether it is changed. So you need to perform well to acquire the certification for this course. So do well. And you also know that those percentage also accumulate from the your assignment solution. So please, if you are not giving those uh, priority base, you are not doing, so that may be in problem, because if you are solving those questions, those are added in your final mark sheet or final certification course. So that will also help you a lot to get the passing marks, or to get the distinction if you want to do good in this course. Okay, so I hope you are getting my points. And if you have any points, if any doubt, you can contact me from to my email ID. And till the next class, uh, signing off this. Okay, guys. Thank you. Thank you for attending the class. See you in the next class. Thank you.